Recording is on. So, preserving and resetting the state. Date 20 June 2024. Time is this. State is isolated between the components. React keeps the track of which state belongs to which component based on their place in the UI tree. You can control when to preserve the state and when to reset it between the re-renders. Between what? The re-renders. The state is tied to a position in a render tree. React builds the render trees for the component structure in your UI. When you give a component state, you might think state lives inside component. When you give a state something like when we provide the state something like this, we might think that the state lives inside the component, but the state is actually held in a React, inside a React. React associates each piece of the state it's holding with the correct component by where that component sits in the render tree. React associate the piece of state it's holding with the correct component by where that tree sits in the render tree. It's all about render tree. So what they are saying, React builds the render trees for the component structures in your UI. Render trees. A UI is described in this form. And React, what you can say, the state is isolated between the components. See, state is isolated between the components. State is not a part of the component. React keeps track of which state belongs to which component based on their place in a UI tree. React state is isolated between the components. React keeps track of which state belongs to which component based on their place in the UI tree. You can control when to preserve the state and when to reset it between the re-renders. So state is tied to the position in the render tree. React builds the render trees for the component structures in your UI. That we know. When you give a component state, when you provide a state to the component, you might think that something like this. If you create this state inside this counter component, you might think that state lives inside this component, but the state is actually held inside React. React associate each piece of the state it's holding with the correct component by where that component sits in the render tree. It's all about the positioning in the render tree. Positioning in what? Render tree. So see what they have done. Counter and the counter. Take this example. Let's do it. Okay. Let's do this same example which clearly defines what React is saying. Now, let's create a new React project. Can you tell me the command for creating new React project? NVM use 18. cd desktop, cd merge stack, cd day 102. Can you tell me the command for create? npm create with @latest. So we are creating a new React project. So state name of the project, state positioning pos, state pos. Hit the enter. We are going to do it with the React TypeScript. So cd state pos npm install. Okay. Now what? Can you tell me what are the next step? Why npm run div? For what? Run the project. Okay. Yeah. So npm run dev. So state is not the part of the component, but React assigns them by the positions in the render tree. Okay, it has been created. Let's delete unwanted things. App.css I don't need. Index.css I don't need. Main.jsx and these things. So there is a meaning for this empty tag. We will see. Okay, so we have one more function. Say my counter const cnt set cnt use state. By default this guy is 0. Now it should return a div and here we can have h3 and the cnt, right? And there would be input type button value. Okay, and on click set cnt, the previous state is equals to previous state plus 1. Whatever you have previous state plus 1. This is also, if you want to get the previous state, you can pass the lambda also. And if you call my counter here like this, localhost, what is the port number? 5173. main.jsx. Can you see it is getting incremented 1450. Now in a, if you write one more my counter over here, okay, so you might think that this CNT is inside my counter, right? See now, style display flex justify content center. What is wrong with this? Inspect console. The style prop expect from the style properties, not a string. So display flex. Oh, got it. It needs an object. Display flex justify display flex justify content center. Can you see I'm incrementing this 8, this is 1 2 3. So what you can understand from here, you might think that this state is a part of this component, this state is a part of this component. So if you write 2 times and if you increment in this component, this might increment in this component also. No, that's what this topic is saying. State is tied to the position in the tree. React builds the render tree for the component structures, in your UI. When you give a component state, you might think the state lives inside the component, but the state actually held inside React. Component has nothing to do with the state, so this is not a part of the component, but React holds this thing. So separate state for this, separate state for this, and that's why whenever you increment inside this component, it doesn't increment inside this, because technically those t. So just a minute. Yeah. So state lives outside. I'm sorry. State lives outside the component. So separate mechanism for this, separate mechanism for this. And that's why this is one component. These two things are one component, these two things are one component. Or flex direction, we can make column. Can you see this is one component, this is one component. And if you want to remove that thing also, align items, this also, center. Yeah. So this much is one component, this much is another component. You are incrementing inside this component, which doesn't mean that it will increment this guy. Although both are the same components, the state is preserved as per the position in the render tree, right? So these are the two separate counters because each is rendered in its own position tree. You don't usually have to think about these positions to use React, but it can be useful in understanding how it works. So the tree would be something like this. And that's why whenever you increment the counter inside, this will increment the counter of this only. If you increment the counter of this, it will increment this only. You don't need to worry about this thing, how exactly this works, right? But it is a good idea to know what is happening behind the scene. In React, each component on the screen has fully isolated state. In React, each component on the screen has fully isolated state. For example, if you render the two counter components side by side, each of them will get its own independent state. That is, in our case, CNT. Each of them will get its own independent CNT. In our case, CNT. As you can see, when one counter is updated, only the state of that particular component is updated, right? React will keep the state around. React will keep the state around as long as you render the same component at the same position in the tree, right? As long as React will keep the state around for as long as you render the same component at the same position in a tree. To see this, increment the both counters, then remove the second component by unchecking the render the second component and add it back, then add it back again, right? So this component has been deleted. Notice how the moment you stop rendering the second component, its state disappears completely. That's because the React removes the component and it destroys the state. React removes the component and it destroys the state. The minute React removes this component, it destroys the state. It becomes 0. Can you see that? 1, 2, 3, 4, 5, 6, 7. It becomes 0. Okay. Now React will keep the state around for as long as you render the same component at the same position in the tree. The same component at the same position in the tree. If this component is at the same position, React will maintain what? The state of this component. To see this, increment both the counters. Then remove the second counter by unchecking. Render the second counter. Checkbox and then add it by ticking it again, and you see that is the 0. Means whenever you remove the component from your render tree, notice that the moment you stop rendering the second counter, its states disappears completely. That's because when React removes the component, it destroys the state. That's because when React removes the component, it destroys the state. We can also do that, not a big deal, but here it getting cleared. So you increment it, then untick this thing, again render the second counter, and you observe that earlier count has been disappeared. Earlier count has been what? Disappeared. Hello? Is that clear? How state works in a React?
Yes, sir. In a code, on pointer enter, there is a set our true,
Mm-hmm.
and on pointer leave set our false. Means when the checking check mark that display, and
Uh-huh.
when the check mark is
No, that is wrong.
not check mark, that
No,
means
your understanding is wrong.
okay.
So that is for the hover, this yellow effect. Can you see on pointer enter hover? Yellow is there. If you see the set hover method, hover has been added. It is for that hover method. Correct?
Yes. Okay.
So I hope you got the idea how React manage the state. Now React preserves the component state as long as it's being rendered at the position in the UI tree. React preserves the component state for as long as it is being rendered at the position in the UI tree. If it gets removed or different components get rendered at the same position, React discards its state. Same component at the position, it preserves the state. Okay. Now if you try to add, see, if you try to, in this example, what we are trying, React preserves the state. React preserves the state as long as it is rendered in a same tree. Means what? At the same position, if you do something, can you see? If fancy, this counter, otherwise this counter. Okay. If fancy is true, means here you are if it is fancy, it's true, then these things would be getting loaded. If fancy is, this is the ternary operator, is fancy, the question mark, right? This is the ternary operator, question mark, and the colon. If fancy is true, this will happen. If fancy is false, this will happen. But this is the conditional rendering as at the same location. When you tick the clear checkbox, when you tick or clear the checkbox, right, the counter stage does not get reset. Some style is getting added, right? And if you click 6, again untick 6 preserved. When you tick or clear the checkbox, the counter state does not get reset. Whether is fancy is true or false, remember that conditional rendering. Conditional rendering, if is fancy is true, this will load, otherwise this will load, right? But conditional rendering means what? At the same position, right? You are just changing the style in other case. So when you tick or clear the checkbox, the counter state does not get reset. Whether is fancy true or false, you always have a counter as the first child of the div written from the app. That's the position is same, right? It's the same component at the same position. So from the React perspective, it's the same counter. It's what? Same counter. So different components at the same position, reset the state, right? So you have removed the component and added the new component again. So it will reset the state. So now, so this is the 0th element, consider that. This is the first element in the render tree. This is the second element. So this is the first, and consider that this checkbox and take a break is a second element. So you untick it. So see you later becomes first, and the take a break becomes second. So if you add it again, see, position has been changed. A different component has taken the position, right? And that see you later has been removed, and again it has came to its original position, which means that the different components, if takes the place in the memory, React will change the state. React will reset the state. Correct? React will what? Reset the state. Hello?
Yes, sir.
Okay. Different components. If the the position in the React render tree gets changed, React resets the state, right? So that's what, from the div you remove this div. So this counter would be getting removed and paragraph would be getting added. So this becomes the 0th component. In this case, this is the 0th component. When you tick mark the checkbox, this component would be removed and this component would be added. So position has been changed. So React will reset the state. That's the thing we discussed. Okay. Now resetting the state at the same position. Resetting the state at the same position. Can you see this guy is getting changed? See here. By default, React preserves the state of the component while it stays at the same position. If in a render tree component is at the same position, React will preserve the state. Usually this is exactly what we want. So it makes sense as the default behavior, but sometimes you may want to reset the component state considering this app. Now see, you just need to change the name. So this is the conditional, again ternary operator, but React is preserving the state. Can you see it is getting preserved, but I want to change or reset the state. How to do that, right? How to do that? Currently when you change the player, score is preserved. The two counters appears in the same position, so React sees them as a same counter whose person prop is changed. But the conceptually in this app, they should be the two separate counters. They might appear in the same place in the UI, but one is a counter for the Tyler and another is for the Sarah. There are the two ways to reset the state. Rendering component in the different position, render the component at the different position, give each component the explicit identity called as key. So if you see here, add next player, can you see resetting the state? Can you see it becomes the 0? So what you have done now, this is not a ternary operator. If you see, these are the two separate components at the zeroth location. If this is true, this component is visible. If this is true, this component is visible. Means you need to overlap the two components over each other, and you have used something called as a prop person. So here you give a different prop, here you give different prop. Okay, so this is the one way, rendering the component in the different positions. Actually these things are at the different positions, right? They are not overlapping. So it is at the different position, it is at the different position. If you see, initially player A is true, so the first position contains the counter state and the second one is empty. When you click the next player, the first position clears, but the second is now containing the counter, right? So each, you can say, each counter state gets destroyed each time it's removed from the DOM. Whenever you remove each counter, its state is getting destroyed. This is why they reset every time when you click the button. This solution is convenient when you only have a few independent components rendered in the same place. In this example, you have only two. So it's not a hassle to render. So you have a minimum components 2. But what if you have 4, 5? At that time, this solution is not good option. Resetting it with what? Key. Now if you see, there is a key attribute we are giving, Tyler and the Sarah. And this, when you give a key, by default, their position is different. See now, there is also another more generic way to do this thing. You may have seen the keys when rendering the list, key prop, when we have rendered the list. Keys aren't just for the list. You can use keys to make React distinguish between the components. See, why to use a key? If you want React to distinguish this and this component, you need to use a key. By default, React uses the order within the parent, the first counter and the second counter. So this is the first counter and the second counter, order. By default, React uses the order within the parent to discern between the components. But the keys let you tell React that this is not the first counter or this is not the second counter, but the specific counter. For example, Tyler counter, right? This key has been attached, Tyler counter. This key has been attached, Sarah counter, right? So these are the two things. Specifying a key tells React to use the key itself as the part of position. Remember that when you write a key, it becomes part of the UI rendering position. React, instead their order, otherwise React will consider the order in which they have written, right? Specifying the key tells React to use the key itself as a part of the position instead of the order within the parent. This is why even though you render them in the same place in JSX, React sees them as a different counters because of the keys are different. So they will never share the state. Every time counter appears on the screen, its state is created, and every time it's removed, the state is destroyed, right? The state is destroyed. So when you say state reserving and presetting, so you need to know when React reserves the state and when React removes the state. So what we have learned over here, React keeps the state for as long as the same component is rendered at the same position. If that component is rendered at the same position, same component is rendered at the same position, React keeps the state. State is not kept in the JSX tags. It is associated with the tree position in which you put that JSX. You can force subtree to reset by giving them a different key. You can force subtree to reset the state by giving them a different key. Don't nest the component definitions or you will reset the state by accident. Component definitions, or you will reset by what we can say the state incidence. So this is what do you mean by preserving the state. This is what the topic is all about. It was theoretical and we have done the practical as well, but this was understanding purpose, and it was very important to understand what the things are happening internally. Okay.
Yes, sir.
Fine, let's call it for a day. We'll meet tomorrow.
Yes, sir.
Yeah, I'm stopping the recording.